Today, let's talk about a magic trick in mathematics. Suppose x squared plus x plus 1 equals to 0. Obviously, x equals to 0 is not a root of the equation. So we can divide this equation by x. So after divide this equation by x squared will become x become 1, and 1 will become 1 over x, and this is equals to 0 again. We take the difference of these two equations, then it will be x squared minus x plus 1 will be cancelled off, and we have 1 over x, and this is equals to 0. And therefore x squared equals to 1 over x cubed equals to 1, and therefore x equals to 1. When we sub x equals 1 into the original equation, we have 1 squared plus 1 equals to 0. Why is it so? Now we try to look at the process again. At the beginning, we are given this equation. Then we divide it by x. Call this as a step 1. After that, for step 2, we take the difference of these two equations and get this. Step 3, we add both sides by 1 by x. And step 4, we multiply both sides by x. And step 5, we get x equals 1. So which of the steps is not valid? After you think through, I hope that you get the answer that from step 4 to step 5, that is not correct. Because x cubed equals 1, it doesn't mean that x equals 1. In fact, x cubed equals 1 would imply that x minus 1, x squared plus x plus 1 equals to 0. And this implies that x equals 1 or x squared plus x plus 1 equals to 0. So from the original equation, we actually get back this equation. Now, there's another question arise. Why we get this extra x equals 1? Why do we get this x equals 1 after the whole process? So this is like a magic trick in mathematics. After some modification, we suddenly obtain a new answer. It is not difficult to answer this question. We can simply say that this is fx. Fx equals to 0. And from the step 1, we actually say fx over x equals to 0. And from step 2, we take fx minus fx over x equals to 0. And from here, we can simplify a little bit, and we will have actually this is x, fx, x minus 1 equals to 0. And from here, we actually get fx equals to 0 or x minus 1 equals to 0. Okay, so after these few steps, we actually come up with a new thing that x minus 1 equals to 0. We want to ask further, why we have an extra solution? Doesn't each of the steps equivalent? And we always see this happen in mathematics. Now I'll give you another example. This is a usual example that we have in secondary school. Let's say we want to solve square root of x minus 1 equals to x minus 3. We square both sides, and we have x minus 1, x minus 3 squared. And this is x squared minus 6x plus 9. So this is it. So x minus 1 is as such. And this is actually a quadratic equation in x. So x squared minus 7x plus 10 equals to 0. X minus 2, x minus 5 equals to 0, x equals to 2, or x equals to 5. We have two possible answers here. Are both of them correct? Now we have to check. If x equals to 2, then the left hand side is equals to square root of x minus 1, that is square root of 2 minus 1 equals to square root of 1, and that is equals to 1. However, for the right hand side, that is equals to x minus 3, x equals to 2, 2 minus 3 equals to negative 1. And we can see that left hand side not equal to right hand side, and therefore x equals to 2 is not a solution. Now if x equals to 5, the left hand side is equal to square root of x minus 1, that is square root of 5 minus 1, that is square root of 4, is equal to 2. And for the right hand side, it is equal to x minus 3. Sub x equals to 5, then it is equal to 2. And therefore we have x equals to 5 is a solution. And the same question arises, why we have this extra answer here? When you sub x equals 2 into the second line, the left hand side is equal to 1 and the right hand side is actually also equal to 1. So if the original equation is start from x minus 1 equals to x minus 3 squared, then we have two answers. However, the original question is equal to square root of x minus 1 equals to x minus 3. So in this case, from a equals to b, we square both sides. And we have a squared equals to b squared. Note that a equals to b implies a squared equals to b squared. However, a squared equals to b squared does not necessarily imply a equals to b. It may be also a equals to negative b. So, using this process, we may have some extra unnecessary solution. And this is an example. Sometimes we can avoid this by looking at this original equation carefully. The left hand side is square root of x minus 1, and it is always greater than or equal to 0. So the right hand side must be also greater than or equal to 0, and this can be only true if x is greater than or equal to 3. So with this condition, then we are able to get the answer very quickly. That is, x equals to 2 or x equals to 5. And because x must be greater than or equal to 3, and therefore we have to reject x equals to 2. Then we need only to check whether x equals to 5 is a solution. It may be also possible that for some equation that it has no solution at all. So back to the question just now, we start with x squared plus x plus 1 equals to 0. Then from this equation itself, we already know that the discriminant is equal to b squared minus 4ac, and that is equal to 1 squared minus 4, 1 and 1, that is equal to negative 3, and it is negative. Since the discriminant is negative, then we can conclude that the quadratic equation here will not have a real solution. And therefore, when we have x cubed equals to 1, we can't accept x equals to 1 as our answer because we know that the original equation will not have any real solution. That's all for today, a simple magic trick in mathematics. I'll see you again next time. Bye bye.